Okay, today we're going to look at rational functions and zeros with the goal of being able to solve rational inequalities. So some reminders. A rational function is going to look like this with the quotient of two polynomial functions. Some things to remember is when the polynomial in the numerator is equal to 0, then the function will have a 0. When the polynomial in the denominator is 0, then the function will be not defined for those points. And we can use that. So remember, if g of x is 0, we're going to have a 0. If h of x is 0, we're going to have the function not being defined. Let's have a go at solving an inequality using this. So firstly, we can see that it's going to have three critical values that's going to change the sign. It's going to have the critical values when x is equal to -6 because of this. It's going to have the critical value. It's going to have the critical value of 2 because of this. Oops. It's going to have a critical value here because of this. If you put in 2 there, you'll get 2 minus 0. 2 minus 2, which will be 0. And our last critical value is going to be at 3. These are our critical values. So we want to put up a number line. Decide where those numbers are. So -6 is going to be here, 2 is going to be here, and 3 is going to be here. What's going to happen is the function may change sign at these points. The function may be 0 at these points. So firstly, we can say that at this point here, the function is going to be 0. At this point here, the function is not going to be defined. So this cannot be included in any domains we give as our answer. And at his point here, the function will not be defined. So we can't use this to give any domains. Next, we need to consider each of the terms in one at a time. So let's start off with this term. This term, we're interested in knowing what the sign of the term is. So what is the sign of the term here at this point? So if we are having values that are smaller than -6, let's say we put in -10, we'll get -4 result. That's a negative number. If we put in a bigger number, such as -1, that's going to give us 5, which is a positive number. So this particular term is going to be positive in this area here. This term will be positive in this area here. Our next one is this one on the top. Putting in 0 will give us -2, that's a negative. Putting in 3 will give us 1, that's a positive. Putting in 2 will give us 0. So this sign is going to be positive. This term is going to be positive in this bit here. Let me collect them together there. So this one's going to be positive here. The third one, this term here, that's going to change and be positive in this last bit here. So we are interested in the resultant function. The resultant function is going to change sign. We've got this point here, -6. We've got this point here at 2. We've got this point here at 3. So that term is negative, positive, positive, positive. This term is negative, negative, positive, positive. This one is negative, 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 and then positive. So the final function is going to be negative here, not defined there, positive here, 0 there, negative here, not defined there, and then positive here. Now let's look at the question. The question wants it to be non-negative or greater than or equal to 0. So we are going to get the bit that we want. The bit that we want positive or 0. So we want that bit, and we want this bit here. Let's write an inequality to express that space. So from -6, we can't include, because -6 is in the denominator. It's going to be not defined there. And the function itself won't have the domain. The domain will not be defined at that point. So for minus 6, we need to go all the way up to 2. We need to go from minus 6 to 2. And then we want to start again at 3, but 3 can't be included. And then we go up to infinity. You might see, let me show you how the mark scheme looks a little bit on these ones. So in the mark scheme, they're sort of noting it in a different way. They don't have a pen and highlighter pens to do it the way I'm doing it. So they're using a similar technique. We've got minus 6, we've got 2, and we've got 3. And what they're writing is this first term is going to have a negative on the top, and the 2 terms on the bottom are going to be negative in this space. Here in this next space, the term on the top is still going to be negative. One of the terms on the bottom, this one is going to be positive, and this one is going to be negative. In the next space, the term on the top turns positive. This one's positive, this one's negative, and in the last space, they're all positive. So that's how it's writing it in the mark scheme. So then it's looking at what the result is. The result is going to go negative, not defined, positive, 0, negative, positive, not defined here. So it's the same sort of approach, but not as colorful, which makes it less fun. Just so you can read the mark schemes. All right. How are we going to start this one? We'll do this one together. How are we going to start this one? We have to factor it. So discuss with the person next. Do you have a go at factoring this one? Have a go at factoring this for yourself, and then we'll have a go at solving. Look. Oh, let me reshare my screen. Okay, so we need to start by factoring this one a little bit. So what did we factor in the numerator? Anyone get this one? Tomorrow. X minus 2? And x plus 2. Difference of 2 squares, yeah? Or the conjugate rule. What about in the denominator? S minus 5 all squared, yeah, excellent. So we've got x minus 5 all squared. This is less than 0. So what are our critical values? What are our critical values? Yeah, these are our critical values. So let's have a go with our number line. We've got minus 2, 2, and 5. Okay. Which term first? The minus 2 is this one, isn't it? That one's going to be here. The next term is going to be this one, which will change at 2. So that one's going to be here. And then this term in the bottom. When is this one going to be positive? Is it just going to be positive here? Well, it's always going to be what? Why? Because it's squared. It has an even multiplicity. In fact, it doesn't have to be squared. It has to have an even multiplicity, doesn't it? So this one's going to be positive for all. Okay, so our result then. Our result. In order to look at our result, we need to determine where is it going to be 0 and where is it going to be not defined. Where is it going to be 0? Let me take the harm. No. Where is it going to be 0? Negative 2. So it's going to be 0 here and here. Why? Because they're in the numerator. They're in the numerator. It's when g of x is 0, the function will be 0. What's going to happen at 5? It's going to be undefined at this point. So we can't include this in the domain because we can't divide by 0. And then we are going to be positive, 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 always positive. The result is going to be, we need to put our negatives in. Is that right? Yeah. And obviously this one, we need to look down now, and this one is going to be positive here. We're going to be negative here. We're going to be positive here. We're going to be positive here. Now we want it to be negative and not 0. We want it to be negative and not 0. So for our result, we want it to be negative and not 0. So between these two poles here, so we want from negative 2 to, negative 2 up to and not including positive 2. Why don't I use the square brackets here for this one? Because 2 is 0. Why is 0 no good for us? Because we're looking to the inequality here, and it says smaller than. It says smaller than, so not including the 0. All right, take 3 minutes to have a go at this one. All right, let's have a look. So what are our critical values going to be for this one? Danny? 3. Why is 2 not a critical value? It's not a linear factor, is it? It's not x minus 2 or x plus 2. It's just 2. What sign does 2 have? So constants like that, you do have to consider what their sign is when doing these type of inequalities. So in this case, it's positive all the time, so I'll ignore it. But if it wasn't, if it was negative, I would have to put negative, 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 negative all the way across. But as it's positive, positives don't really do much. Only negatives cause problems. That's why it's important not to be negative in life. Okay, we're going to go straight to the answer on this one. So what happens at 3? What happens with the function at 3? Okay, who are the zeros in the group? Who are the zeros in the group? Obviously, it's undefined. Why is it undefined at this point? Because it's in the denominator, and you can't have a negative denominator. I mean, 0 denominator. Okay, where is it positive? It's going to be positive in this space here. So we're already at our answer, aren't we? X is greater than 3. So you can answer with an inequality if you want. You can answer with an inequality like this, with the infinite inequality. You can answer with the interval notation. You can set up an inequality to look like this. Although I know that some math teachers don't like the third one, it's still equivalent formats of the same concept.
You said negative all the way, numerator was negative. What do you mean by that?
All right, let me do another example like coming up from that question. So if that question was slightly different, let's say we had minus 2 over x minus 3, and we want greater than 0. So with this particular problem, we draw our number line. Our critical point is still 3. This linear factor here is going to be positive here. But in this case, this term here is going to be negative throughout. So we would have to figure out what the resultant is going to be, because we've now got negative, negative, not defined, positive, negative. So our resultant in this case is going to be x is less than 3. All right. Have a go at this one for yourself. 3 minutes. Let's go. All right. So I'm going to make it a little bit easier for myself, and I'm going to start by rearranging the inequality and factoring the top. I'll take the 4 out. I get x plus 2, and I can see the linear factor easier. On the bottom, I have x plus 5, and we want this to be less than or equal to 0. So, what are my critical points? What are my critical points going to be? So we're going to have a critical point at negative 5, a critical point at negative 2. So my first factor, let me take this one first. My first factor is going to be positive here. My first factor is going to be positive here. My second factor is going to be positive here. Don't ignore this term too much, really, but in this case, it's easy because it is positive all the way through. That 4 is going to be positive all the way through. So my result, got a minus 2, got a minus 5. We are going to be negative, positive, positive, negative, negative, positive, always positive. Our result is going to be positive, negative, positive. So we look now to the inequality. We want less than or equal to 0. So where do we have a 0 and where are we not defined? Do we have a 0? A negative 2, we're going to have a 0. And negative 5 is undefined because it's in the denominator. So we want less than or equal to 0 as our answer. That means we want that bit, don't we? So our result is going to be negative 5 up to and including negative 2. As an inequality, negative 5 less than x less than or equal to negative 2. Okay, have a go at this one for yourself.